So hello everyone. Among other activities, the Leonard Incubators is having 2 startups programs. One is the seed for early stage startups to help them reach their product market fit. And the other one is Catalyst to help startups and scale-ups boost their collaborations with the Vinci Group. Tonight, the theme is Builders 4.0, and we have selected 5 startups that may shape up the future of our sector. So we'll have the 5 pitches, then some questions from the audience and from you guys on the internet. For the chat, I will be your voice at the end of the pitches. So the order will be Converge, Modulous, Voyage Control, SafeAI, and Constru.ai. Raphaël, I think you go. Please keep it short.
Can you hear me?
Yes.
Perfect. Well, thank you so much. Really excited to be here today and tell you a bit more about Converge. So, as you just mentioned, I'm the co-founder and CEO at Converge, and Converge is all about digitizing the physical construction sites using sensor data and AI. So as I'm sure you've heard today, the construction industry is one of the most fundamental industries. It's a foundational industry, but it's got a huge productivity and sustainability, $1.6 trillion labor productivity gap, and it contributes to about 11% of global carbon emissions. And our aim is to digitize the physical world on the job site to close that gap from an efficiency, a safety, and sustainability perspective. And so we deploy sensors on the construction site, sensors on concrete to help understand the behavior of concrete on the project, but also sensors on the environment, sensors on the structure to understand its behavior and its performance, and sensors on assets that might be prefabricated or offsite construction materials, as well as plant and machinery like the crane. And we feed all that data into what we call our physical intelligence engine. And our physical intelligence engine fuses that physical data that we gather from sensors with construction data, which might include your BIM model, the Primavera P6 schedule that you might be holding on the site, economic data that might exist in the SAP or ERP system you're using, and sustainability data. And by fusing these 2 data sets, we're able to actually start using AI to produce actionable insights that allow the construction sites and the construction companies to actually optimize the way they operate. Now, that's a pretty kind of big vision, and we ended up focusing on a very specific process or productivity loop that exists on the construction site, and we built Concrete.ai. And Concrete.ai is made up of 2 components, a data platform that helps you optimize the construction of concrete structures by informing things like striking times, and a sensor that you can see here on the right. It's called the Converge signal. And the Converge signal is fully embedded in concrete and gives you real-time data on the strength of that concrete, which means you can know in real time when to strike or tension or move on to the next element. There's a mobile app and a data platform that gives you real-time data, provides you with notifications. And actually, one of the things we've done is we've also trained an AI. I mean, this is the world's first AI that is able to predict the behavior of concrete given the weather forecast. So we'll take a few hours of data on the behavior of a slab, the weather forecast, as well as the type of concrete you're using, and we'll be able to tell you with over 95% confidence when a piece of concrete is going to hit strength, and as a result, when you can start sequencing availability of workers to do things like striking a formwork. And you can see it was first used at, which was a major project in the UK, where we helped them save close to about a month of construction, 4-month construction window. We link that data into the BIM model as well, which means the project managers and engineers on the site get real-time visibility in a very visual way about progress on the construction sites, and get kind of that data contextualized. But more importantly, are able to actually run some analytics as well on how long it takes to build different floors, and then also start running analytics at kind of company level across different sites. The technology has been used by some of the largest construction fields. Obviously, the Vinci Group is a key partner, and thank you for organizing this event today to showcase that. But we've also worked with in the UK companies like Langerook or Mace, or in the APAC markets with Gammon Construction, as well as in some cases owner-operators like Transport for London or the Changi Group who run the airport in Singapore. And it really is expansive in terms of the types of projects. It goes from high-rise that you can see 22 Bishopsgate, where we're involved in London at the top right, but also the metro in Singapore, precast factories, bridges, infrastructure such as tidal barriers that have used the technology. And actually, just to briefly show you a case study with the Vinci Group, we were working with one of the Vinci Group companies called Taylor Woodrow in the UK, where TfL was actually upgrading the White Hart Lane station. So this is an existing railway station that was being upgraded to support a new structure. And it had, I mean, if you look at the layout of the project, 13 piers. Piers were supported by a number of foundations, and Taylor Woodrow had to build 8 underpins underneath each pier, made out of concrete. And the strength of concrete in that kind of construction sequence was pretty critical. So if you look at the actual activity here, Taylor Woodrow had to excavate underneath the existing kind of railways that you see here, pour some concrete, wait until that concrete reaches 2 newtons per millimeter squared, or 2 MPa, before they could then grout or inflate a grout bag. And once that underpin was completed, they had to wait until 15 MPa was reached before they could excavate the next day. So you can see that all these activities are highly strength dependent. And then when you look at the original kind of planned program or cycle for each element, they expected that it would take about 2 days per element. And actually, we were able to turn that into a 1 day per element cycle, saving approximately 50% on program, which is huge. Now that this is ultimately just the beginning, we're building 3 new products now beyond concrete DNA that look at structural health, that look at prefabrication and the location of prefabricated assets, that look at utilization of cranes, with the vision that ultimately they all feed into construction DNA, which is that kind of aggregator and physical intelligence engine that kind of links data from different sensors across the site to provide insight to both the construction job site as well as the enterprise. And that's an introduction to Converge. So thank you so much for listening.
Thank you. Thank you, Raphaël.
Thank you. So should I just leave the room now, I guess? Sorry about that.
Hello. That's your turn. You can share your screen if you want.
Yes, just finding it there. Can you hear me okay?
Yes. And we
And
see
you got my screen?
It's perfect. Go.
Perfect. All right. Good evening, everybody. Really glad to be here. Thanks for having me. My name's Chris Mortensen. I'm one of the co-founders and COO of Modulous. We're a London-based technology, construction technology business, and really we've set out to transform how housing is delivered. Now, after many years of frustration in this industry, our team decided it was time to change out and really look at how we revolutionize the way homes are delivered. When we look at the global landscape, we understand that there's a chronic housing shortage across the world. The population has nearly doubled in my lifetime alone. Housing dynamics are changing at a cost of upwards of $6 trillion just to keep pace with the need today, and we just don't have an industry to do it. And when we look at the UK alone, the backlog is 4 million homes, and that growing deficit is about 140,000 homes per year. And it's clear that a complete change in approach is vital for us to come to grips with this and deliver sustainable homes to the people that need them. Now, in 2017, our team, and it's rich in delivering some major projects from the Emirates Stadium to Google headquarters building, we decided we wanted to refocus what we were looking at and really look and converge our energy on transforming the way homes are delivered. And for us, the only solution was to build what we're calling the fast track solution. And that fast track platform is a process that digitizes the design process and allows for third-party assemblers to deliver homes locally to those projects. And so what does that mean? With an automated design platform, a standardized kit of parts that's built from an exceptionally high performing kit that is designed to be easily and rapidly assembled, along with a fully integrated supply chain, we're able to develop and deliver sorry, my slides here have stopped. We're able to deliver beautiful, comfortable, safe, stylish homes. Now, apologies, my slides have just jumped like 3 forward. Technical difficulties. One moment. So really the secret behind our transformational change is the integration of our standard kit of parts and that automated design process. Now, for us, the kit of parts is one of 3 data sets that we use in that automated design process. The other 2 are local building codes, and that third key set is the developer brief. So in our system, the developer can jump onto the platform, they can upload the plot of land that they're looking to develop, and they can start to feed in all that data. In this case, residential, multi-story, choose 1, 2, 3 bedrooms, extent of outdoor space, podium, whatever they want. Now, with this information, we run thousands of iterations of that project on that particular site. And in the first instance, we're looking at return on investment, right? We're looking at what's feasible, what's not feasible. We have the land values, we have potential revenue, we have cost to build, and we want to establish which options work and which don't for that client. From here, we select the options that we want to look at further, and we can dive into some more advanced engineering analysis, whether that's wind modeling, energy analysis. In this case, we're looking at direct sunlight analysis for building orientation and pedestrian comfort. Now, once we've refined that, we can export to our BIM model, and we can start to refine and adjust that manually. We can start to look at floor plate layouts. We can even start to change elements of the facade from our library of components. And the same works for the interiors as well. Now, at this point, we have a very high level of design. And because we know everything that's going into that design building, we have a true cost that we could feed back into the client, and we can start to feed that into our supply chain. We can interrogate that supply chain and start to build up a robust program for assembly and construction. Now, I mentioned earlier that we have a distributed method of assembly, and so our logistics partner collects all those components from our supply chain and delivers those in a just-in-time and just-in-sequence to our assemblers local to that project. Now, while high-performing, our kit of parts is relatively traditional to start with. Precast slab with surfaces cast in, tracks for walls, sleeves to pick up those columns. We've got a wet wall system that is pre-plumbed, floor and ceiling cassettes with services built in, and we just put those modules together and transit to site. Now, we're looking for our assembly partners to be able to assemble 9 units a day, and 9 because that's typically what a crane hook could lift on a mid-rise building such as this. Now, that means we can install the modules for this building in about 16 days. So if we look at a few months up ahead for groundworks, podium, and core, and then after the modules are landed, second fix for internals and facades fit out on site, it means we can reduce the construction time of this project from, say, 18 months to around 6 months. Now, where we are currently today, we're currently working on 5 pilot projects in the south of England. However, we're looking at a few projects in the northern part of the UK and Scotland, and also a few projects in Austria. We've been recently nominated to deliver on a large framework in the north of the country for 40,000 homes over 5 years, and are in discussions on a similar framework in Germany for 100,000 homes over 10 years. Now, in both of those cases, our system enables the local authorities and businesses to run designs, procure locally, and assemble locally and deliver those homes themselves. Now, really, to sum up the Modulous system, the fast track system is really there to enable landowners and developers to deliver high quality, sustainable, affordable homes at scale and pace. And our business model is one which not only works here in the UK, but in any country that has an appetite for this style of design and a mature supply chain. And with our seed funding closing imminently, projects starting on site in next month, and further developments on our technology, we're looking for partners, collaborators, clients, investors. So if you'd like to come on the journey with us, feel free, contact us, and we'd be delighted to meet with you. Thank you.
Thank you, Chris. James, yeah, I see you there. You will be connected. James, you're on the screen. You can share your presentation.
Excellent. G'day, everyone. Hope you're well in the various bits of the world you're in. Hopefully you can see the presentation up on here as well.
It's good.
Excellent. Thank you. So to give you an understanding of what we do, our platform is really there to help our customers all around the world manage their logistics and supply chain activities. We initially started in the world of industrial last mile deliveries into construction sites, and then sort of went into resource management, which is all about managing tower cranes and hoists, and more recently inventory control, so some of our customers can have an understanding of what's going on throughout their supply chain. On top of that, for some of our customers, there are some very significant issues that they need to resolve around managing congestion problems and meeting compliance requirements of the projects that they have. To give you a sense of our what we're doing globally, we actually started in the events industry in the United Kingdom back in October of 2013, and then expanded into construction in sort of 2015, 2016. We now work with about 30 very large construction companies all around the world, many of whom you might be familiar with from the names that are on this board as well. Not only do we work directly with construction companies, but we also work with a number of owners and developers that exist. The two parts of the value proposition that exist for our clients on a construction side is firstly around delivery management and really ensuring that they're maximising the use of all of the assets available to them on a construction site, as well as compliance and looking at supply chain performance. The inventory control module is for some of our more sophisticated customers who are really interested in understanding what is going on the whole way through the supply chain. And then the next version of Voyage Control, which will be coming out next year, will be integrating both logistics and supply chain management with project schedules. Something that we've been working on for a while and we're really excited about is our partner program, sort of emulating the success of what Procore have been doing for the last few years. We have about sort of a dozen integrations in place, which will grow to about sort of 2025 by the end of this year, across a multitude of different requirements that our clients have globally. Just to delve into three really quick client examples for you. This is the largest infrastructure project in Australia that we're supporting a couple of construction companies on, where the platform is supporting not only the operational requirements of the construction project, but also supporting the compliance requirements that exist with a client who is City Metro. One of the cool integrations we've built out, which is now live here, is with What 3 Words, so that people have a really good understanding of where they need to be. A second one, which is our most sort of advanced supply chain project, is this multi-billion-dollar project in the United States with Madison Square Gardens, where not only is the platform being used at the construction site itself, but it's also being used by all of the major construction subcontractors through the process. And our platform is fundamentally responsible to help with the proof of delivery and the payment applications that happen. And then just finally, this is Suffolk Construction, another enterprise client of ours in the United States. Something that's really great with Suffolk is we've just finished a case study talking about how we're saving them about 10,000 management hours a year by using our software. Hopefully that's a good quick canter through Voyage Control, and look forward to talking to you more about Voyage Control. Thank you.
Thank you, James. And thank you. Thank you to stay so late. Brenton, Australia, so it's roughly 3 a.m. in the morning for him. Hello, Brenton.
Can you hear me okay there?
Yes, you can share your screen.
Just tell me when it's coming through.
It's good.
Okay, thanks very much, everybody. My name is Brenton Welford. I represent a business at SafeAI, based here in Australia, where we're retrofitting vehicles for autonomous applications in mining and construction. So I just wanted to start, it depends who you speak to. Autonomy in mining especially, and to a lesser extent in construction, either it's something that's already been done or it's something that's 10 years away. It's seems to be very rare that you're speaking to someone who's looking to automate their equipment right now today. And so I want to talk to you a little bit about the problem, where I think that comes from. Right now, even at 2:30 in the morning, there's approximately 500 autonomous heavy vehicles operating in the Pilbara, and to a lesser extent other places around the world. Those vehicles are in reality and running on a technology from somewhere between 5 and 6 years ago, mostly by the large-scale OEMs, Caterpillar and Komatsu. You have to admit that that's a pretty good, successful execution of that model. However, it hasn't scaled to all the other vehicles, and it hasn't really scaled out of mining into construction and to other industries like quarrying and aggregates or forestry to the great extent so far. And the reason is because it's expensive. It requires sites that have a long life of project, 10 years, of the kind that you get in the major iron ore players. So that pretty much cuts out construction of even of capital projects of a 1 to 3 year, and it cuts out the second-tier miners and the smaller miners. The good news, somewhere around 2014, technology took a bit of a step change in the autonomy industry, mostly based around the automotive. Sensors are becoming cheaper, and the method of autonomous vehicles is the onboard perceptual system. So our job is to take these insights from the automotive industry, bring them back to mining, bring them back to construction. When you have an onboard system, you're able to rely less on very heavy infrastructure. It costs a lot to set up a remote site with large-scale LTE or a large-scale backhaul in order to get the information back to a remote operations center. So as you can going in the automotive industry with cars, or autonomous cars on roads that might be 10 years away, we are having this capability now for a limited subset of the applications of autonomous driving in mining and construction environments. We also have a development on that side of how to manage that, the fleet management system that goes with operating those vehicles. So what have we done so far? We're still at a fairly early stage. This is a vehicle that we have managed to retrofit and have working currently in Arizona. It's a 793F, one of the most common trucks from Caterpillar's range. In the bulldozing side, there's also a bit of added perceptual work involved in detecting and looking at the push to location of piles in dozer push application. Right now, sorry, this is just a stock image and not our actual image, because it's just starting this in this last 2 weeks in October in San Francisco, or in the Valley area. So we have a 725C for construction, one of the most common vehicles in the construction industry, 30, 40 ton range. And on our test facility, we have 2 vehicles that are mostly there as surrogates, but for proving out applications, including the F-150. And you might have seen this little guy running around. So you've got the skid steer. It's a surrogate vehicle also for our bulldozer and loader applications, testing out the software there. So that's the list of the range of the kinds of vehicles that we're currently working in. And where it's sort of headed, I suppose, involves, which kinds of applications are going to be particularly returning in ROI for customers in construction. And most of that is presently around load and haul, bulldozing, and particularly around utilization more than replacement labor. So in summary, autonomous technology, some people have dubbed 2.0. It relies on it being taken decisions. We're working in an open, interoperable ecosystem. We're allowing customers to get access to their own data from their vehicles, not locking them up in particular fleet management systems, being able to integrate that in the rest of their mine or construction management. And a retrofit method is much easier and simpler, cheaper than integrated, bought brand new method by an OEM. So thank you very much.
Thank you, Brenton. And he is also in Australia. Ohad, you will be able to join.
Yeah, hi. Can you
Hi.
hear me? Here?
Yep.
Okay. Let me share. Okay.
And
Hi, everybody. Can you see my screen? Everything works properly?
Perfectly.
Great. So my name is Ohad Snir. I'm the VP of Business Development at Constru. What we do, so that was SafeAI is a great segue to what we do. So we're bringing kind of an autopilot to your job site. And let me tell you a little bit about the founder and how we came to do that. So our three founders coming from both the construction world and from computer vision. So Ron, our chief scientist and co-founder, was one of the founding team for Mobileye and other computer vision companies. And the idea is to bring the same revolution for autonomous vehicles, as Brenton was talking about earlier, to the construction space. We currently have 3 offices, so headquarters in Tel Aviv, Israel. I have an office in New York, an office in Belgrade, and working with owners and contractors around the world. And you heard from 4 other companies before me what are the issues that the construction space is facing. So I think that all of us are talking about the delays, over budget, general risk, and low quality. And in our view, it's all coming from the lack of data. And this is what we're here to solve. So we're taking one methodology, which is computer vision, and how can we use computer vision to bring more data to the space, help companies to digitize the space, index, analyze, and basically enrich your world with construction data, so you can take better decision, have more visibility, and so on. So how do we do that? It all starts with 360 cameras off the shelf, and using our app to take photos of your job site. All these photos are being uploaded to our cloud, and with deep learning and computer vision networks are analyzed for the purpose of the system will understand every image in a similar way to a human engineer that understand the image. So it can understand what is happening exactly on the job site, understand specific elements, and all this information can later be translated into insights. That creates a closed loop construction process, as we call it. So start with the documentation, going to the platform analysis, and then insight and analytics are being provided to the construction company or owner. And this is being done on a very high cadence, so it can be done daily, weekly. Weekly is the lowest cadence that we recommend. So what is it exactly? Imagine you have 1,000 engineers on site. So it's gonna think about your engineering team and the construction team just being multiplied and given superpowers. The system is providing value in 3 layers. So the most basic layer, this would be the 360 job site visibility. So taking images and access the job site at every given moment. The next stage is the system is detecting discrepancies between plan and build using computer vision and a comparison to 2D or 3D models. And then the top value is the ability to track progress in a very granular level. And I'll show exactly how it's being done. So first of all, on the 360 documentation and access, you're taking images of the job site on a weekly basis or a daily basis. And then back at the office, everyone can access the job site and walk around the job site in 360, compare different dates to one another. Then the Next phase is integrating with BIM, integrated with BIM 360 or other BIM models. And what you can see here on the left-hand side is how the BIM model is being built, and on the right-hand side is the actual image and the computer vision element detection that the system is doing, so it can compare the real-world element to the planned element. That allows the system to detect discrepancies, as I said. So here, that's the full list of discrepancies that it detected on a specific project. And what you can see here is a specific example of a door that was detected, which was out of place and not in the plans as the plans were uploaded to the system. So the super or the project manager can go one by one. It's kind of a automatically generated live punch list that they can review. Then the next phase is the ability to actually tracking progress of the job site. So I'll show you kind of the behind the scene of how the system is doing it from a computer vision perspective. So between every set of images that they're taking on a weekly basis, the computer vision network detect different elements that were added. So here we can see this is the ceiling, and we can see the top tracks that were added here. And then the HVAC and pipes and studs and wrapping and so on. All this information is being poured into an easy-to-use progress tracking tool that is breaking down every milestone into the sub-activities and every location on the job site, and allows you to understand for every given date what is the exact status of the job, and with completion rate and a visual understanding of whether or not the job was started, in progress, or completed by now. It also generates an as-built Gantt schedule that then being compared to the planned schedule. All this information is being presented on a management dashboard that shows you in kind of one place your schedule analysis, the completion rate analysis, and the quality analysis and discrepancy monitoring. On the top here, you can see the breakdown by basically by trades, and on the bottom, it's a breakdown by location, and everything is kind of clickable, and you can go into more granular or less granular as you wish. And then finally, all this, so I was talking about data. So the system is basically digitizing every image and understanding what's the status of the job site. All this information is being poured into our database, and there are two options to play with this data. So one is kind of ready-made reports that can be generated from the system. The other is the ability to slice and dice the data in pretty much any way you can think of. So plan % complete, earned value analysis. These are just some of the reports that customers were interested in and were generated for them. And then finally, the value that we're bringing to the table. So we're seeing accelerated timeline in projects that are using our system, reduced costs and better quality. But most important is the ability to mitigate risk and to use the data to streamline processes or to put new processes in place and take data-driven decisions. That's Constru. Thank you very much. Happy to chat with anyone that is interested. Thanks.
Thanks a lot, Ohad. You can stay on, and I will ask all the other startups to connect with us. If the audience has questions, we have a mic there, and I'm waiting to see on my screen if there are questions from the internet. You can come up to the mic.
I have a question for Voyage Control. Are you in France already?
Not yet. We work with Bouygues, and we are having discussions with other clients, but we don't have any active construction sites in France at the moment.
Maybe I will jumpstart a few questions before we get those from the internet audience. Maybe Raphaël, for you, are you able to deal with any type of concrete?
Absolutely. So every concrete mix that we work with would kind of get calibrated typically. So the short answer is yes. The longer answer is we've been doing some really interesting work actually with novel types of concretes. In some instances, actually with the Vinci Group, for example, green concretes, either fly ash or slag-based kind of replacements like GGBS. And that's actually one particularly really interesting area where we've seen the typically when GCs want to move to kind of green concretes, they suffer a productivity downside. They'll take longer to cure. But by coupling the converged signal and concrete DNA product with some of these cement replacement-based concretes, we're able to help contractors significantly reduce their carbon impact by, but also bend the cost curve. So they're able to bend both the cost curve and the carbon curve at the same time.
Okay, thank you. We do have questions in the audience.
Hey guys, this is Guillaume from Leonard. I wanted to call a question to Brenton because you're the only one. Oh, I look weird. You're the only one I haven't met yet. But how do you? And it's a little bit of a shitty question because I'm asking about a competitor. How do you differentiate in terms of your strategic approach to built robotics? The other.
So, yeah. Thank you very much. So. It's a good question. So there are other retrofit operations out there. One of the ways we differentiate is focusing on a specific market, and rather than taking sort of a bespoke strategy for particular vehicles, particular custom clients, we're taking a couple of the most common and vehicles. For specific applications. So, for example, it's a little bit goes into a little bit more into the use case and the value case of a site, right? But take a mining example of a dozer push. Just because you automate a bulldozer for one particular application, we've repeatedly feeding a hopper and over again, it doesn't mean you've completely automated a bulldozer for every single task that it might be used for. So our focus is really working with customers' insights to identify what are the applications, use cases with a vehicle and something that the vehicle does that are really going to save money over a long period. For example, in mining, we're working at the moment with an hour shift as a utilization benchmark that's coming from the big OEMs like Caterpillar and Komatsu, not the sort of other retrofit operations they mentioned. And so that is very much one application that can scale in a large way across industry. So basically in our approach to doing the business is where we differentiate.
Thank you. While we wait for other questions, maybe one for Chris. What are the states of your relations with architects? Are they happy with you?
Yeah. So when we first set out on this project, one of the goals, because we all come from, or a lot of the founding group comes from a design background, and we were really looking to digitize ourselves and almost replace ourselves. What we found over the course of the last 2 years is architects and others on the design team are really interested in utilizing that design tool because they can start to do some of the concept work up front, look at maybe more high value work for them, and then leave the detailed design to a system such as ourselves. And because we're built on a construction as opposed to sort of everything for everyone, we can do the details, and that's inherent in the platform that we're building. So for us, we're finding that we're actually working with architects more than we thought we probably would at the start.
Great, thanks. James, it will be your turn. What are the usual KPIs to measure the impact of Voyage Control on the construction site?
The key one that a lot of our customers are focusing on is the savings in management time that they have at the moment. For some of our customers, it's then about managing or seeing what the supply chain is doing in terms of who's showing up on time, are the deliveries correct, and what the KPIs that our customer is trying to understand in terms of improving the quality of their supply chain. Unfortunately, many of our customers have never really looked at this beforehand, so it's very much starting from a very low starting point.
Great. And Ohad, maybe one for you. And how do you deal with the complexity and the specificity of every construction site? How do you adapt?
Yeah, so that's a good question. So currently, our network is trained for over 250 different jobs. In every construction site, there are probably new jobs that we haven't seen before, and the algorithms and the network is always developing. We do have men in the loop for these type of cases in order to, first of all, deliver the value and train the algorithm. So in a few weeks, they're able to automate the process.
Are there any other questions from the audience? I'm not seeing ones in a... Yes, maybe one.
I have a question for Ohad. It seems that everybody that's working on deep learning application is engaged in some kind of race against the others to gather as much data as possible. Do you think that this is going to be the main factor for your success, or it's really about the secret sauce of the algorithms and the fact that you have, people that have managed to build those things for the first time in different industries? Like, how do you go about thinking about this and convincing investors that it's not going to be about brute force?
Yeah, so actually, there's no really an issue of lack of data. It's fairly easy to collect the data, and I think that everybody in the space have at least enough data to train the computer vision network that we need to train. So I would say that it's less about data. It's about different methodologies and different technologies and the know-how for people who are doing it. So people in Constru were involved in companies from, as I said, Mobileye, Trax that is using computer vision to analyze retail stores, Orcam that is using computer vision to help disabled people to see. So I would say that it's more about the know-how and the experience than it is for data, although data is very important for every computer vision and deep tech company. But it's currently not a barrier for us.
Okay, well, thank you guys. I think you have been very clear. We have no questions anymore. Maybe you can put it in your emails in the chat if people want to directly connect with you guys. And you can also contact me and I will put you in contact. Tomorrow is the last day of the festival, and we have 2 events, one at 9 and one in the afternoon. And thank you guys, especially those in Australia. It's really late for you. And we'll see you soon.